This is Dr. Brown. Today we're going to talk about polynomial and rational inequalities. In fact, what we're going to be doing is we're going to be solving a polynomial inequality and solve rational inequalities. And solving them, we mean to find out what values of x satisfy the inequality. For example, we want to solve a polynomial inequality, and we want to use this graph. And the inequality is to solve x plus 3 times x minus 1 squared more than 0 by graphing it. So we're going to now bring up the calculator and clear out the equation and put in the graph of x plus 3 times x minus 1 squared. And let's graph this, zoom to the standard window, and we want to find out exactly where this graph is more than 0. Well, it's pretty obvious that it gets to be 0 at x equal minus 3, goes back, it's above 0 all the way from x equal 3 or more than 3 up to x equal 1. And at x equal 1, it's equal to 0, so it's not more than 0. But beyond that, it's more than 0. So, looking at the graph, this is a little bit more artistic picture of it. We can see that solution is the heavy line that I've drawn here, all the way up to x equal 1, not including 1, because at 1 it's equal to 0, and then beyond 1. So basically it's for x more than minus 3, less than 1, or x more than 1. We can also write that in interval notation from minus 3 to 1 in union with the set 1 to infinity. Now let's take another one. X to the 4th more than x. We could graph x to the 4th and graph x and just see where one graph is above another one, but a simpler way is to subtract x and look at x to the 4th minus x is more than 0. And we'll go ahead and graph it. I've got the results of it right here. Let's make sure you can put this into your calculator. We put x to the 4th minus x clear that, x to the 4th minus x, and zoom to the standard window, and we probably want to zoom in a little bit, so let's change the window from to minus 3 to plus 3, and from like minus 2 to 10, and graph it And now you clearly see that this graph is more than 0 if x is between minus infinity and 0. And then, of course, it dips below the x-axis. And then when it gets to 1, from 1 to infinity, it is, again, more than 0. So our solution is to set minus infinity to 0, and then from 1 to infinity. You can also show it on the line going from minus infinity to 0, not including 0, and then going from 1 to infinity, not including 1. So using the same techniques we use to solve polynomial inequalities, we can solve rational inequalities. Suppose we wanted to solve x minus 1 divided by x squared minus 4, find out when it's more than or equal to 0. Let us graph the inequality. Here is the result here, but let's do it on our calculator and go x minus 1 divided by x squared minus 4, and then now zoom to the standard window. And now we have the graph that shows the vertical asymptotes. And now we want to find out where this graph is more than or equal to 0. So a solution is when it's equal to 0 or more than 0. So you see going from minus 2, it's above 0, more than or equal to 0. All the way to x equal 1, where it becomes 0. And then on the other side of the plus 2 horizontal vertical asymptote, it's above 0 from minus 2, not including minus 2, plus 2. Let's start over again. We have the graph here, and we see that the graph is more than or equal to 0 for x more than minus 2, all the way to 1, including 1. So it's more than or equal to 0 all the way up to 1. In fact, at 1 is exactly equal to 0. And then beyond 2, it's greater than 0 all the way to infinity. So we would write minus 2, x more than minus 2, less than or equal to 1, and x union with x between 2 and infinity. One more rational inequality we can solve algebraically. The equation 3x squared plus 13x plus 9 divided by x plus 2 squared is less than or equal to 3. What we want to do is subtract 3 from either side and come up with the equation, this expression minus 3 is less than or equal to 0. So what we do is we graph the equation, clear it, and do 3x squared plus 13x plus 9 divided by x plus 2 squared. Minus 3. And then let's zoom to the standard window. And so we want this function to be less than or equal to 0. And we can see that that happens between minus infinity over here and the vertical asymptote, which is at minus 2. So it would be between minus infinity and minus 2. And then between minus 2 on the other side of the vertical asymptote and x equal 3. And to see that, we have zoomed in here on the right and notice that a 0 for the function is at x equal 3. So all the way from minus 2 to 3, including 3, because at 3 is exactly equal to 0, and that satisfies being less than or equal to 0. So the full solution is minus infinity to minus 2, union with the interval from minus 2 to plus 3, including 3. And that is section 5.4.